Hi, in this video, let's look at combinational and sequential circuits. Combinational circuits are made up of basic and universal logic gates, that is, basic gates AND, OR, and NOT, and universal logic gates like NAND and NOR. And here, the output at any given time will be dependent only on my present input, only on my current inputs, that is, here you can see x and y are my outputs and it is dependent on a, b, c, d. That is, my x and y can be expressed as a function of my current inputs. So this is like the basic definition of combinational circuits, and to give one example would be an adder circuit where it is dependent only on the current input at any given instance of time. Now let's look at its classification. So these are divided into three basic types, that is arithmetic and logical functions, data transmission, and code converters. Arithmetic and logic functions, like I already mentioned the example of adder circuits, it can be subtractors, comparators, etc. And data transmission, like multiplexers, demultiplexers, encoders, and decoders. And code converters, like to convert data in one form to another, like binary to decimal, etc. So those all circuits are combinational. Now let's look at sequential circuits. So in sequential circuits, the output is dependent not only on my current inputs but also on my previous outputs. So because it is dependent on the previous output, I need some storage element. So that because of that reason we have a memory element. So this memory element will store my previous state or previous outputs that will be used for my current state result. So my input and my previous output will give me output at any given instance of time. So this is a basic example of sequential circuits definition. So now let's look at one example like counter circuits. So at any given point of time, so suppose I'm counting till 5, then my previous count is 4. So I need to know my previous count to get my count at this instance of time. So because of that, sequential circuits need a memory element. Now let's look at its classification. So there are two different types, synchronous and asynchronous. So one basic difference between these is synchronous have a clock, asynchronous do not have a clock. So because it has a clock, the output will change at particular instances. So suppose at positive edge of clock or positive level, so at that time the output changes. So it is dependent on the clock. So because it is dependent on the clock, it is also called as clock the sequential circuits. Whereas asynchronous, it does not have a clock and it does not depend on the clock to change its output state. Now let's see the difference between combinational and sequential. So most part of it I've already explained. So here output depends only on the current inputs. Here it depends both on current inputs as well as past states or outputs. And it does not require memory element. It does require a memory element to store my previous state. And clock signal is not required. Here clock signal is required because I have to synchronize my state changes between the previous, present, and all of that. And because here there is no memory element, simpler design, because it's made of only logic gates, basic and universal logic gates. Here it is complex because I need memory elements like flip-flops, which are more complex in design. And examples, adders, subtractors, and multiplexers, whereas in sequential counters, which I already mentioned, shift registers and flip-flops. So that's all. Thank you.